Uh, Welcome again. And now we'll be doing univariate equations. Uni meaning one, variate means variable. We'll be doing one variable linear equations. Now, of course, in our last video, we talked about what is an equation generally. An equation, we said, it is when you take two mathematical expressions and then you divide them by an equal sign. Meaning you take two mathematical expressions and then you put an equal sign in between them to form an equation. If there's no equal sign, then there's no equation. But now we want to specify, when we talk about linear equations, what do we mean? Now, a linear equation is any equation that can be written in this form. Some may say ax equal to b, some will say ax plus b equal to c, but there's one thing in common is there should be number or numbers, there should be a variable. Now you will notice what I explained last time. Here this variable x. Notice that this variable x, the exponent, it has a coefficient which is not x, and it's not a variable. It has x, and this x has an exponent of 1. If it was square root or x cubed or maybe log a to the power x or whatever the case may be, then it would not be the kind of value we are working with. But of course, because it is log x, because it is ax plus b equal to c, it is linear and x has the exponent 1, where a, b, and c are constants. When you talk about constants, we're saying whatever value you choose for a, b, and c, it will remain that way. So if you were to say, okay, I want my a to be 1, I want my b to be 0, I want my c to be 3, then for this equation, those values will not change. If you change those values, you have changed the equation. We're no longer talking about the same equation now. Whereas with x can take any value because it is a variable. It's not a constant. Remember, when you talk about constants, we're saying if you choose that particular value, a remains that value for as long as you're talking about that equation. You change the value of a, you change the equation. Now we're talking about a new equation. So that's what we mean by constants. It means they will always remain the same for that equation. So let's talk about making x the subject. Now, when you're solving for x, it's no different from what we did in our previous video, where we were talking about solving for x. In our case, we said we're making c, we're making b the subject, but we're basically solving for c, which is the same principle here. Now, the rules not change. As we did with c, you put everything, all the variables you are concerned or you are interested in, put them on one side. Now, let us look at this. You've got x. X is negative on the right-hand side. Now, how do you remove negative x? You add a positive x. And if you add a positive x on the right, which will give us 0, you should add a positive x on the left, which will give us positive x. Now we've got 6 there. We want to remove that 6 because that 6 has no x. So how do we remove a positive 6? We put in a negative 6 on the equation. And the 6 and the minus 6, they cancel out. And then if you put 6 on the left, we should also put negative 6 on the right. And we have that negative 6. Hence, we've got the equation. This is the equation we have. So 2x plus x is equal to this, minus 6 plus 3 is equal to this. And then you divide by 3x. And then by making x the solution of the equation, you have solved for x. This is basically what it means. Now let's go for the second one. Now before we go for the second one, I want us to just explain what we're talking about here. So we've got 2x over 3, 3 over 5. Okay. Now, here's the problem. The objective of basically solving for x or solving the equation. There are many terms you can use. But the whole objective, or the one thing they have in common, is we want the value of x such that the left and the right are the same. That's what it means. We want the value of x such that the left and the right are the same. Now, the algebra goes as follows. Put all this side. Remember, you can say subtract both sides, but of course that's going to be a long route. The best or the shortest route will be to say, if I'm going to subtract this both sides, then on this side, I'll have this. And then I've done nothing here because it already has the x I need. And if this is negative, if I'm going to add this both sides, I've done nothing here. If I'm going to add this both sides, it means I'll have a positive of this. Basically, what we're saying here is, if it's on the left, if it's on the right hand side, and then it crosses the equality sign. If it's on the left, it crosses the equality sign, it changes sign. So this one was positive, it crossed, changes sign to be negative. This one was negative, it crossed, it changed its sign to be positive. Crossed from negative to positive, crossed from positive to negative. Or you can apply that long method where you say, okay, I'm going to add 3 over 5 both sides, which of course will get you this. I'm going to subtract x over 6 both sides, which of course will give you this at the end. How you do it is, of course, up to you, ladies and gentlemen. Any method to me is fine, as long as it's a method that works, as I always say. Now, the LCD. Because we've got fractions, we are going to use the LCD. Remember the LCD, I gave you notes on it to read on your own, because LCDs are not part of our syllabus, but they apply. So, what is the LCD between 3 and 6? It's 6. I'll let you go investigate on your own, whether you're using YouTube or whatever platform you use. how do you get the lowest common denominator? So 6 over 3 is 2 times 2 is 4x. Take the sign as it is. 6 over 6 is 1 times this 1, you've got 1x. And then you've got the LCD of this side, which is 5. 5 over 1 is 1 times 4 is 20. Thus, 5 over 5 is 1 times 3 is 3. Then on this side, you've got 23 over 5. 4x minus x is 3x over 6. But if you use a calculator though, 23 over 5 is still 23 over 5. Nothing changes here. If you use 3 over 6, you've got what? 1 over or x over 2. Now, we want to remove this 2. Remember, the 2 is dividing. How do you remove something that divides? You multiply throughout. You multiply the whole of the left. And if you multiply the whole of the left, you multiply the whole of the right. So I multiply by 2 everything. I multiply the whole side by 2. So that this 2 and this 2, they cancel out and I'm left with x, which is what I wanted. And then on this side, I've got 23 over 5 times 2, and I've got 46 over 5. I do hope we all understand. Now let's go back. And see how we did it. Now, as I said, you take this on the left, becomes negative, the one that is negative becomes positive, you find the LCD, and then it gives you this value, you simplify it, and then you got x over 2, and then you multiply it as we did, so that you get 46 over 5. Let us look at A. Now, with A, of course, you've got 4 over A, you've got plus 8 over 9, got negative 3 over 8. Now, let it be clear, the only equations you guys are dealing with are linear equations. I want us to be very clear on that. The only equations you guys are dealing with are linear equations. So, you guys are going to always have to consider that when you do your work. If it's quadratic, it must be turned into linear. I don't know how. Questions might differ. Maybe the questions will differ, but you should know that you always work with linear equations. So let's work. Remember, all your unknowns, one side. So take this side. Remember, it's negative, so it becomes positive. We've done nothing here, so we keep it as it is. And then this one is no A, so we take the other side. It's positive, so when it crosses, it becomes negative. I hope we're clear. What is the LCD? The LCD between A and A is what? A over 8 times 4, 4. A over 8 times 3, 3. Equal to, there's nothing to add here. Then you've got 7 over 9 equal to negative 8 over 9. Now, remember, this is 8, not 9. Now you've got these two fractions. We want them to multiply. So we have what we call cross multiplication. What does it mean to cross multiply? It means to take the one on the bottom right, take it to the top left, bottom left, take it to the top right. You know what I mean. Now, we've got 9 times, if the bottom right goes to the top left, we've got 7 times 9. Remember, it's called cross multiplication, not cross addition. And then we've got negative 8 times 8, and we've got negative 8. 7 times 9, we use the calculator. 7 times 9, 63. And you've got negative 8a. Now, of course, you can keep this as it is, but I always prefer to put my variable on the left. And then I want to make a the subject, not negative 8a. So I divide throughout by negative. What do I have? A, because these two will cancel one another. And your negative should never be at the bottom. It should always be at the center. So you've got negative, either at the center or at the top. So you've got negative 63 over 8. And this is the value of your A. Now, let's see how it was done again. Put in one word, find the LCD, and the value, we cross multiply, and then A is 63. Sorry, negative 8a. Sorry, that value should be negative 8a is equal to 63, so that we divide by negative and we get the value negative 63 over 8. Now, let's go to bivariate or simultaneous equations. Now, a bivariate equation or a bivariate linear equation in particular is an equation that can be written in the form that. Now, I want again to note your x and your y, they both have exponents which are 1 and the coefficients which are not variables, as it is stated that a, b, and c are both constants, and so it's not ants, it's n, x and y are variables. If they are variables, it makes it a bivariate. If there were 3, it would be trivariate. If there were 4, it would be multivariate. But you can still call it a multivariate because remember in English, many starts from 2. Now, if you want to solve these equations, first of all, if you have 2 variables, you must have 2 equations. You cannot have 2 variables in one equation. There's no solution to that. To solve 2 variables, you must have 2 equations. To solve 3 variables, you must have 3 equations. Now, the first method of solving our simultaneous equation is the elimination method. Now, this is where we remove or we eliminate one variable so that we can solve the remaining variable. So if you've got 2 equations, we will use these 2 equations to cancel one of the 2 variables. Now you can use any of the 2 variables. So you can use any of the 2 variables to solve the equation and cancel the other. It doesn't matter if you're solving for x and y. It doesn't matter whether you start with x or you start with y. The important thing is one of the 2 variables must be removed. And then whatever remains, you solve that. After you are done, you come back, but of course we'll see the step. The second method is the substitution method, where you use one equation to substitute for the other. But of course, we'll see to that. The elimination method. Now, the steps for the elimination method are as follows. First, you make the coefficients to be the same. Otherwise, if the coefficients are not the same, the variables can cancel each other. Remember what we said about opposition? We want the variables to have the same magnitude, but different signs of that variable. So if we are cancelling x, we want to convert the equation such that we have, for instance, this is an example, we have, for instance, positive 6x. Then to cancel, we must have at the bottom negative 6x. But of course, we will see about that. Then we will simplify whatever we get when we are doing the cancellation process. Then we'll substitute whatever value we have back to the other variable, and then we can obviously check the solution. The substitution method takes a different route but gives the same solution, whereby you use the two equations and express a third equation where you will make one of the two variables the subject. The third equation will be found by making one of the two variables from one of the two equations the third equation. And we'll see what we mean by that. And then we'll substitute whatever variable, the third variable will be substituted to the other variable. So for instance, if you use equation 1 to find equation 3, then you will substitute equation 3 to equation 2. Just like if you use equation 2 to find equation 3, you will substitute equation 3 to the unused equation 1. And then we know we have one equation with one variable which will be solved. Remember, two variables, two equations. And if we use equation 3 to substitute for the other, it means we will cancel completely the other variable, or we will have substituted completely for the other, and we'll be able to solve with ease. And then we're going to use the solution to check if the first equation, so whatever we get from the solution we have of that first variable, we can now take any of the two equations and substitute to get the other one. Let's take this. Now we'll just first browse what we mean. Now, here's the thing. You want the solution by elimination. 3x plus 4y is equal to 33. 2x minus 3y is equal to 5. You can substitute with any. In our case, we'll eliminate x. Now, if we eliminate x, we have to make the two variables be equal. And if we make them equal, the first equation will have 6x and 8y, while the second equation will have minus 6x plus 9y. Remember, the first equation we multiplied, we are removing x. Let's note we are removing x. So we multiply by 2, we multiply the bottom by 3, so that we have 6x plus 8y equal to 66. At the bottom we have negative, multiplying by negative, such that now we have these two variables. And then when you add these two, remember, 6 minus 6 is 0, so nothing to add with. Whereas 8y plus 9y is 17. 66 minus 15 is 51. And 17, when we solve for y, 51 divided by 17 is 33. Then we say, after you have found the value, you then substitute to any of the two equations. You can use 1, you can use 2, it's supposed to give you the same. But if you use the first equation, we put 3 instead of y, we get the value 3x is equal to 7, and then x is equal to 7. This is the elimination method. So I want us to redo this equation by hand now, instead of looking at it at the slides. Let's do it by hand. So we have 3x plus 4y. Okay, let me put it here. 3x plus 4y, 33. 2x minus 3y equal to 5. Now, we are saying we want to eliminate this value. How do we eliminate this value? Simple. You take the coefficient here, you multiply it. You multiply the whole equation, not just the x. You multiply the whole equation. And then you take the coefficient here, you multiply. No, forget the signs at the moment. You take this, you multiply at the bottom, you take this, you multiply. So you take the bottom, you multiply at the top, you take the top, you multiply at the bottom. If we are multiplying with, if we are trying to remove x. Now, what do we have? We want these x's to have the same magnitude. The magnitude is as the value, but different signs. Meaning, if one is positive, the other one must be negative. And according to our example, we made the bottom one negative. So what do we have? At the top, we have 6x, 2 times 3x, 2 times 4y is 8y, 2 times 33 is 66. And then we have negative 3 times 2, which is negative 6. Negative 3 times negative 3 is positive 9y. Negative 3 times 5 is negative 15. Then we add these two equations. Negative 6 minus 6 is 0. We don't count that. This is what we wanted. We wanted this. We wanted them to have same magnitude, which is 6. We wanted the same magnitude, which is 6, but different signs. This one is positive, this one is negative. If they do not have the same magnitude, then they won't be able to cancel each other. We want same magnitude, which is 6, but different or opposite signs, so that we get a 0, which is what we want. And then here we've got 8 plus 9, which is 17. It doesn't really matter what you have here, as long as the one you want to cancel has cancelled. Then 66 minus 15, which is positive 51. Then y is 3. When you use the calculator, 51 divided by 17, you will notice it is 3. And then we are saying use any of the two equations. Now, we used 1 for the first one. I'll use 2 now. So I have 2x minus 3 into 3 and 5. And I've got 2x minus 9 minus 9 equal to 5, which means 2x is equal to 5 plus 9, which is going to be 14, which means x is equal to 7, which is the same 7 we found on our first solution. So any of the two equations will suffice. But now, let me, instead of cancelling x, so instead of eliminating x, let me eliminate y instead. Now, I want to eliminate y. Now, fortunately, for our part, the signs are already opposite. Unlike here, when the signs were the same. Here they're already opposite, so there's no need to work with the signs. But what we do want now is to make sure that since we want to cancel or we want to eliminate y, let's make sure that they have the same value. How do we do that? We take what is at the bottom, we multiply with it at the top. We take what is at the top, we multiply with it at the bottom. The signs are already opposite, so we don't need to worry about the signs. Then 3 times 3 is 9x. 3 times positive 4 is 12y. 3 times 33 is 99. 4 times 2 is 8x. 4 times negative 3 is negative 12y. 4 times 5 is 20. So when you add these two values, what do we have? 9 plus 8, 17, equal to 99 plus 20. I do not know that value. I had 119. Let us see if it gives us the same value. It gives us 7. Go figure. 109 divided by 17 gives us 7. Now we take any of the two equations. I will take the first one this time. Now I want to solve for y because I've already solved for x. So I say 3 into 7 plus 4y equal to 33. And this is 21 plus 4y. 33, and then 4y is equal to 33 minus 21, which is going to give us 33 minus 21, which gives us 12. And then what is y over 12, which is 3. Now you can see that y is equal to 3, y is equal to 3, x is equal to 7, x is equal to 7. It doesn't really matter which equation you use. The solution will always be the same. But you, of course, will not do both methods unless you are instructed to do so. You will only be required by your lecturer to use only this particular method. Now, we've already established. Now we use the substitution method. Now, as I do the substitution method, you get the first equation, you get the second equation. Now you use one of the two equations to make equation 3, and in this case, equation 2 will be used to get equation 3. So this is equation 2. This then becomes equation 3. And then we substitute to the unused equation. Now, if you use the equation 2 to make 3, then it means 1 is not has not been used. That means we take 3 and substitute to 1, which has not been used. Because if we substitute on 2, we'll get 0 equal to 0, which takes us nowhere. So we want to take it to the 1 which has not been used. And then this is 1. We then substitute wherever we see x, because we made x the subject. So wherever we see x, we put in that right-hand side, which is what we did here. And then we take the LCD, send in y equal to 1. Now you'll notice that this, once we reach this spot, the elimination method, it cancels out a lot of steps when we use the substitution method. There are a lot of steps that it cancels out, because with the elimination method, we move from here and then jump straight to this part. So all of this part is cancelled out. But of course, it's not compulsory to use it. And then once we found our y, we substitute back, and then we find our x, and this becomes the equation. Okay, let's use our method. 3x plus 4y equal to 3. 3x plus 4y equal to 33. 2x minus 3y. Okay. Now, what does it mean? We said, first of all, you let this is how you start. Let this be equation 1. Let this be equation 2. Now, what we did, we decided to let equation 2 be we decided to let equation 2 be used to substitute for equation 3. Now, let's take that approach. We made x the subject. So first things first, if you want to make x the subject, remember what we did in the first section. Take everything that does not have x. This is equation 2. Take everything that does not have x to the other side. And we want to make x the subject, not 2x. So we divide throughout by 2. And remember, we divide the whole side. And this is the whole side. So x is equal to 5 plus 3y, all divided by 2. And then this becomes 3. Only once you've made that variable the subject do you then consider it as equation 3. Until then, it's not equation 3. Wherever we see x, we put in the right. Wherever we see the left, we put in the right. Now, equation 2 comes from 3, which means we must take 3. If this one has already worked, this one has not yet worked. This is the one we'll be using to solve for. If we made x the subject for 3, that means we are solving for the one that is not the subject. So if we had made y the subject, then that means we are solving for x. So we made x the subject, means we will start with y. So wherever we see x, we put in this. So we've got 3. Remember, 3 multiplies everything that is x. What is everything that is x? This is everything that is x. And then now we apply chord mass before we apply reverse chord mass. Multiply everything inside. 3 times 5 is 15. 3 times 3 is 9y. All of that is divided by 2. Remember, 2 is only for this part. It's not for everything. Then we find the LCD because we want to have only one y. Let's apply the LCD so that we've got 15. Sorry, what is the LCD? The LCD is 2. Or, okay, let's do it this way. Let's do it this way. What is the LCD between 2 and 1? It's 2. Okay. The LCD on the left hand side is 2. What is the LCD? What is the denominator on the right hand side? Is 1. What's the LCD between 2, 1, and 1? It's also 2. So you multiply by the LCD of the equation. That's also another method. There are multiple methods you could use. So I'll multiply throughout by the LCD of this, the LCD of here, the LCD of here. What is the LCD? It's 1. So I multiply everything by 2, so that 2 and 2 cancel, and I'm left with 15 and 9y. So that I've got 2 times 4, which is 8y. I've got 2 times 33, which is 66. And then I've got 9y plus this, which is 17y, which is 15 on the side, which is 66 here. And then I've got 17y equal to 66 minus 15. And then I've got 17y, which is going to be 66 minus 15. And then I have 51. Then y becomes 3. Same method, same way we did it, but I apply a different method, particularly on this step. But it's up to you, whatever suits you. And then we move further. We then say, okay, now that we found y, we need to find x. Now, you can use any of these two or this. I always prefer, when you use substitution method, always use the one where x is already the subject so that it doesn't complicate things. So you already know what your y is. Your y is 3 divided by 2. And then you simply use a calculator. What do you have? 5. Sorry, plus 3 into the y, which is 3, and then divide all of that by 2, and what do you have? 7. So between x and y, you've got 7 and 3. Now, as we are going to conclude this lecture, I would like us, in our own time, to do these particular exercises. If anyone has a problem, they can come to me. I want us to do those particular exercises, which of course will be part of your tutorial and eventually your quiz and tests. So this then concludes our lecture on solving for x and solving for x and y simultaneously. Thank you very much.